Also, this is not for students that are here. It's for students that are at home. Yesterday, I told you guys all the answers, right, for the ones we skipped. I did that without before I turned off the video recording, and then I told you guys. So this is for people that are at home. You guys that are in the classroom, you don't need to copy this down. You already know this. Answers for the ones that I skipped over. Question number 10. A couple of the answers on number 10 are -5 and 1. -5 and 1. Number 12. A couple of actually, I'm only going to give you one answer. Is -5. -5. Number 14. A couple of answers are 2 and -1. 2 and -1. And number 16, a couple answers are, oh wait, no, I didn't do, oh yeah, 16, -5, I'm going to give you three answers, -5, 1, and 4, -5, 1, and 4. Okay, so, all right, so we're going to back up and hit number 15 now, question number 15. And it's like what we were doing at the end of class yesterday. They want all the zeros, and they give us g of x equals, don't put g of x equals, put 0 equals, we're finding the zeros here. So we have x5 plus 3x4, x5 plus 3x4, plus 3x4, minus 4x3 minus 2x squared, minus 4x3, minus 2x squared, minus 4x3 minus 2x squared, minus 12x minus 16, minus 12x minus 16. So while you're copying that down, totally off topic. I know that as of right now, sports, it's like the 21st is when they're going to be able to, they're going to talk about whether they're going to open things up again. As of right now, what about restaurants? Anybody know about restaurants? One of these, is it the same? Anybody know about that?
No. They open Monday, or like the 1st of February.
To sit down and eat?
Yeah.
In Michigan? No, there's not any restaurants
It
up
was
there.
25% capacity.
What's that?
I go back to work Monday.
Go back where?
I go back to work the 1st of February in a restaurant.
So people can come in and sit down and eat in a restaurant?
Yeah, it's just more restrictions.
Where at? Where do you work at?
The gardens and Coolwater.
People can go in there and sit down and eat. I didn't know that.
Yeah.
Okay, all right. Because I mean, the restaurants I've been to, it's all takeout, and which is fine. But it's like, we like Mexican food, and it's like, I don't care where you get it. You get Mexican food in cold water, and you drive back to Union City. By the time it's good, but it ain't as good as eating it there. It gets a little cold and all that. So okay, all right. What do you do at Coldwater Gardens? Waiter? Okay. All right. Okay, so this is 5th degree. I'm going to give you three answers. I'm going to give you three of them, and they are -4, 2, and -1. -4, 2, and -1. Let's write those down. -4, 2, and -1. Make sure I said those right. -4, 2, -1. Yep. So we're going to do synthetic division three times. Three times, okay? So in the box, we're going to put -4. It doesn't matter which one we put first. I'm going to do -4 first. Do we need to put any zeros in? Well, we have x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and then a number. We don't need to put any zeros. We didn't skip anything. So we put 1, 3, -4, watch the negatives, -2, -12, and -16. And we're going to do synthetic three times, which means it's better end in 3 zeros. Okay? So we drop our 1 times 1 and -4, you get -4. Add 3 and -4, you get -1. Times -4 and -1, you get +4. Add 4 and -4, we get 0. -4 times 0 is 0. Add 0 and -2, you have -2. -4 times -2 is +8. -12, oh, we said February, okay, I'm stupid. You kept saying February 1st, didn't you? It ain't February yet. For some reason, you said February 1st, and I heard January 1st. Okay, so okay, so yeah, they haven't opened up yet, because it's not, gotcha, all right. It's been a long week. So, all right, so -12 and 8 is -4. -4 times -4 is +16. Add 16 and -16, and you get 0. So far, so good. It ends in a 0. Then I'm going to plug in 2. We're going to plug in 2. Okay, we drop our 1. Times 2 and 1, we get 2. Add -1 and 2, we get 1. Times 2 and 1, we get 2. Add 0 and 2, we have 2. Times 2 and 2, we have 4. Add -2 and 4, we have 2. Times 2 and 4 to 4. Add -4, 0. Times 0, add 0. So now it ends in 2 zeros, so far so good. Now we're going to plug in Okay, so we drop down our 1. 1 times negative 1 is negative 1. Add negative 1 and 1, we have 0. Negative 1 times 0 is 0. Add 2 and 0, you have 2. Negative 1 times 2 is negative 2. Add 2, we have 0. Negative 1 times 0 is 0. Add 0 to 0. Times 0 and negative 1, 0. Add 0 and 0, you have 0. So it ended in 3 zeros, which is fantastic. That's what we wanted to do, is end in 3 zeros. So we have a remainder, a remainder, a remainder. We're supposed to have 3 remainders of 0. This is our number. This is our x, and that's our x squared. So what this says is x squared plus 2. X squared plus 2. Okay? And that sort of factors, okay, this is sort of tricky, okay? It's kind of a sum of squares. Kind of a sum of squares. If you remember, if it said x squared minus 2, that's kind of a difference of squares. That's obviously a square, x squared. 2, you don't normally think of as a square, but it kind of is. It's the square root of 2. That would have factored x plus radical 2 and x minus radical 2. Okay? Well, if it's a sum of squares, it factors with imaginary numbers. This factors to x plus radical 2i and x minus radical 2i. Okay? It's sort of a sum of squares. So our other answers are negative radical 2i and positive radical 2i. Okay? And do they probably have I radical 2's. Yes, they do. Okay, and I don't know if I ever told you guys this or not. Instead of radical 2i, you usually write it as I radical 2. And the reason is, if I had 4 radical 3, you write it as 4 radical 3. You don't write it as radical 3, 4. Any idea why? Especially the way I write it. Any idea why you probably wouldn't write it like that? What's it kind of look like? Looks like radical 34, okay? Especially if you have bad handwriting like me. So generally, whatever is outside the radical, you put it in the front. So instead of saying radical 2i, it's I radical 2, and this should be negative I radical 2. Okay? So, we have 5 answers. Click on this, and then negative I radical 2 and positive I radical 2. Okay? All right. The next couple questions are really, really, really quick, easy ones. Really simple, easy ones. Okay? Well, to get to number 17, it's filling in the blanks. Okay? I'm going to do a very quick rough graph. Very quick rough graph. It looks sort of like this. Okay? If you look on number 17 on your computer, it's going to look sort of like that. Okay? They want to know how many, in this order, how many imaginary solutions, and they also want to know how many real solutions, and the total number of solutions. Okay? Now, they also tell you one more thing. It's 4th degree. This is a 4th degree equation, or a graph of a 4th degree equation, okay? Let's start with this. We're not going to do them in order, okay? Let's do the number of real solutions, okay? Now, if you can't answer this, it's not the end of the world, but in about 2 seconds, you should be able to answer it very, very easily. How many real solutions are there on this one? Anybody have a guess? Let's do this. Let's do the easiest one. How many total solutions are there if it's 4th degree? 4. You can't miss that. There's 4 total solutions, okay? The number of real solutions is 2. Why? Yes, sir.
Because there's 2 points that touch the x-axis.
Touches the x-axis here and here. There's 2 real solutions. Now, what are they? I don't know. I don't care, okay? How many imaginary ones is there then? How come 2? Yeah, because 2 plus 2 is 4. I mean, if you take all the imaginary solutions and all the real solutions, you have all the solutions all together. If there's 2 real, there's got to be 2 imaginary because it's 4th degree. That's it, okay? Let's look at number 19, another easy one like that. Looks same type question. They're asking us this right here. Graph looks like this. Same ones right here. I want to know the imaginary. How many imaginary? How many real? How many total? Okay? It's just filling in the blanks. They're going to ask you how many real, how many imaginary, how many total ones are there, okay? And this is degree. This is a 2nd degree equation. Now, if you're wondering, how do you know that? It says, the computer tells you it's 2nd degree. Okay? So how many total solutions are there? 2. None. Why?
Because no point touches the x-axis.
It never hits the x-axis. Now, it hits the y-axis, but who cares? We care about where it hits the x-axis. There are no real solutions, so there's got to be two imaginary. If there's two total solutions and none of them are real, then both of them have to be imaginary. Okay? All right. Those are the easy ones. Now we got one more type of question we have to talk about. And I'll be done up here. All right, next one is number 21, I think. Yes, it is. Okay, number 21, we've already did a question like this a few sections back, okay? They want the polynomial, the zeros are -5, -1, and 2. Zeros, -5, -1, and 2. I think that's what I said. -5, -1, +2. Okay, -5, -1, +2. They want you to come up with a polynomial in standard form with those zeros, okay? So the first thing we do is we put it in factored form, okay? Now, if you forgot about this, just want to make sure you understand. If I give you this right here, is that in factored form? If I give you y equals x plus 3 times x minus 5, is that in factored form or not? Is that factored? What do you guys think, yes or no? Yeah, why? What's the tip-off that it's factored? Yeah, it's got parentheses. That's factored, okay? That's in factored form. This is a factor, and this is a factor. These are what are called factors. X plus 3 is a factor, and x minus 5 is a factor. The zeros are -3 and +5. Zeros are just numbers. Factors are x plus something or x minus something, okay? So here's what we're going to do. We're going to put it in factored form first, okay? So if -5 is a 0, x plus 5 is a factor. If -1 is a 0, x plus 1 is a factor. And if 2 is a 0, x minus 2 is a factor. You just put the opposite, x and then the opposite. Okay, the opposite of -5 is +5, opposite of -1 is +1, opposite of +2 is -2, okay? Now we're not done, because they don't want it in factored form. They want it in standard form. Standard form, well, I erased the problem we just had in standard form. So you got to multiply this thing out. Now, in case you forgot about this, how do you multiply three things together at the same time? You guys remember talking about that?
You do 2.
Yeah, how do you times 3 at once?
You can't.
You can't. You have to do 2 at a time. And it doesn't matter which ones. I'm going to do these two first. It really doesn't matter. I'm going to FOIL these out, okay? So first times first is x squared. Outers is x times -2, that's a -2x. Inners are 1 times x, that's 1x. And last is 1 times -2, that's -2. Now, before you multiply by x plus 5, I would really encourage you simplify that. Okay, put those together. So x squared, -2 and 1 is -x minus 2, then times by x plus 5. So we're going to multiply each of these three terms first by x, then each of these terms by 5. So x times x2 is x3, x times -x, and be careful, some students will say those cancel. X and -x cancel when you're adding. We're not adding, we're timesing. X times -x is -x squared. X times -2 is -2x. Then we multiply by 5. Times x squared is 5x squared. 5 times -x, -5x. 5 times -2 is -10. Now we put together our like terms. There's nothing that goes with x3, but we have a -x squared and a positive 5x squared. That's 4x squareds. When we put together a -2x and a -5x, it's a -7x. Okay? Now, just from a review, this problem's done, okay? But just a little bit of review, make sure you haven't lost some of the stuff we talked to you about. This is third degree. Does it ever touch the x-axis? Yeah, how many times?
3 times.
3, where?
-5.
-5, -1, +2. So how many real answers are there?
3.
How many imaginary ones are there?
None.
None. There are no imaginary solutions, okay? If it's third degree, there's 3 solutions, and if they're all real, none of them can be imaginary, okay? All right. Let's try a couple more, and then I'll be done up here. There's one more little thing we have to talk about while we're going over these last couple questions. Still going? Yes, it is. Good. All right. 23. Okay. They give us zeros of 3 and 4 plus I. 4 plus I. Okay. Jot those down, then just listen, okay? These are your zeros that they give us. Now, based on what I've told you, you should answer this wrong, okay? If you've learned it, you'll answer this wrong because we have to alter what I've taught you, okay? They gave you 2 zeros. So what degree is this going to be? They gave you 2 zeros. What do you guys think? You should say second. You're wrong. That's based on what I've taught you as of right now, okay? Here's why, okay? Imaginary solutions always come in pairs. They always come in pairs, okay? So, and they come in pairs, what are called conjugates. Conjugates, okay? Conjugates are kind of like opposites, kind of. If I gave you this right here, 8 plus 3i, the conjugate of 8 plus 3i is 8 minus 3i. If I gave you 7 minus 4i, the conjugate of 7 minus 4i is 7 plus 4i. Now, some students go, those are opposites. No, they're not, okay? The opposite of positive 7 minus 4i would have been negative 7 plus 4i, okay? When the opposite is everything's the opposite, okay? Conjugates, write that out right here. Conjugates, they're exactly the same except for you only change the sign in between them, okay? So what you need to understand is imaginary answers always come in conjugates, okay? So if 4 plus I is a 0, what's another 0 that I didn't tell you that you need to know? 4 minus I is. Now listen carefully. If 3 is a 0, must negative 3 also be a 0? Why?
Because it's not imaginary.
How do you know that?
Because it's real.
How do you know that?
There's no I.
Very good. There's no I. Okay? If it's, now, so again, right here, negative 5 is a 0. Must positive 5 be a 0? No, it can be. It wasn't. Okay? Real ones don't have to come in pairs. Imaginary ones always come in pairs. Okay? So, 3 is a 0. Must negative 3 be a 0? No, it's not imaginary. But if 4 plus I is, 4 minus I is. Okay? So, and I guarantee you on your next test that you'll take it another week and a half or so, there's going to be a question like that. Okay? They'll only give you 2 of them. So, let's put down our factors. Y equals x minus 3. Now be careful on this, okay? We put x minus 3, that's not a problem, okay? And then put x, and you're minusing all of this. You're minusing 4, and you're minusing I. Okay? You change the signs on all of them. And then you put the last factor, x, and you're minusing 4, and you're minusing minus I. So instead of saying minusing minus I, we're going to say plus I. Okay? Now, we've just said a few minutes ago that it doesn't matter which 2 you multiply first. I would really, really encourage you multiply the ones that look most similar. Okay? Which ones look most similar? The first 2 or the last 2 or the first and the last? The last 2, okay? We're going to do those first, okay? I would definitely do those 2 first, okay? So we're going to multiply this. I'm going to multiply each of these first by x, then each of these by negative 4, then each of these by negative I. So x times x is x squared. Write small. You're going to be writing a lot of stuff on this one. X times negative 4 is negative 4x. X times I is xi. Now this is going to get to be a mess, but it's going to clean up real nice real fast once it gets all messy. Now let's times by negative 4. Times x is negative 4x. Negative 4 times negative 4 is positive 16. Negative 4 times I is negative 4i. We all done with that one? We still have times by negative I. Negative I times x is negative ix, or negative xi, same thing. Negative I times negative 4 is positive 4i. And negative I times positive I is negative I squared. A negative times a positive is a negative. I times I is I squared. Now, that's a mess, but
Yeah.
look at it carefully. How's that going to clean up?
Nothing cancels out.
What's that?
They cancel out.
A lot of stuff cancels out. Anything cancel with xi? It's kind of hard to see this one. There is something that cancels with xi. Are those opposites? Ix and x negative? You see, these cancel. Negative xi and positive xi, those cancel. Keep looking. What else can we cancel, guys? Negative 4i and positive 4i. Those are gone. Okay, now we can't cancel these, but we can put them together. If it was a negative 4x and a positive 4x, it would cancel. Okay, but one more thing here. What is I squared?
2i.
Well, now remember what is I squared? I, remember for imaginary numbers, is the square root of negative 1. I squared, this is something you've got to memorize. I squared is negative 1. I squared is negative 1. Okay? So, this is negative 1, but it's negative 1. So what is this? So what can I put? This is 1 right here. What can I put 1 with? 16. So we have 17 there. And what else do we say we can put together?
Negative 4x and negative 4x.
That's a negative 8x. And what else do we still have?
X squared.
Okay. Now is this entire problem done? No, we still have to times by what? X minus 3. So we're going to multiply each of those first by x, then later on by negative 3. Watch your negatives. X times x2 is x3. X times negative 8x is negative 8x squared. X times 17 is 17x. Then times by negative 3. Not 3, negative 3. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 8x is positive 24x. And negative 3 times 17 is negative 51. You can use calculators. So if we times everything by everything? Yep, we all done? Almost. Clean it up. Nothing goes with x3, but negative 8x squared and negative 3x squared is negative 11x squared. 17x and 24x is 41x. Minus 51. So, it's third degree. Does this graph ever touch the x-axis?
No.
Yeah, how many times?
3.
Once. Why? Two are imaginary. Two are imaginary. Now, if you can answer this is fantastic, okay? If not, it's not a huge deal, but, listen to the answer, okay? True or false? Must every odd degree graph touch the x-axis? Must every odd degree, if it's like 5th degree, does a 5th degree graph have to touch the x-axis? Does a 7th degree have to touch the x-axis? Does a 11th degree have to touch the x-axis? What do you think? Must they always touch the x-axis? Are you guessing? Any guesses? It's okay if you don't know it yet. Why? Because you're guessing right now? Or do you huh? So, why do they have to touch the x-axis? Does an even degree have to touch the x-axis? No. I mean, if I give you this right here, y equals x squared plus 1. That's a parabola moved up 1. How many real answers that thing got? 0. Why? Never touches the x-axis. So, how many total? There's 2 total zeros. If none of them are real, there must be what?
0.
Well, 2 imaginary. There's 2 imaginary zeros. 2 imaginary ones, okay? Must an odd degree always touch the x-axis? The answer is yes.
Yes, because it's the weird looking one that goes through that, right?
Yeah.
Good. I was hoping you weren't going to say that, though. You're right. I'm looking for a different answer, though. You're totally right. Yes. Okay? Another reason is this, okay? So I'll give yes.
Is it because it bounces?
Not necessarily. It doesn't have to bounce. It's a good guess, though. Okay. Let me ask you this. This is kind of another way of asking the same question. Could a third degree, odd degree, touch the x-axis in exactly 2 spots?
No.
Why can't it have 2 real solutions if it's third degree? If there's 2 real, and I only said this once, so that's why you probably aren't getting this right now, okay? There's 3 solutions and 2 are real. What does that mean? There's got to be what? One imaginary. What's wrong with that? Can you have one imaginary solution? Why?
Because
They come in pairs. Imaginary ones come in pairs, okay? So, if it's odd, it has to touch the x-axis because they're going to come in pairs, okay? Which means there's always going to leave one out that's not, if you have if it's 17th degree, could they all be imaginary? If it was 17th degree, could they all be imaginary solutions? Well, no, why?
Because
Right, and they come in.
pairs.
If I have 17 students, can I pair everybody up?
No.
Somebody's going to be left out, okay? Somebody has to be left out, okay? So they can't all be imaginary, therefore there's got to be at least one of them that's real, so it's got to touch the x-axis, okay? If you got that, great. It's not a huge deal if you don't, though, okay? But yeah, odd degree, have to touch the x-axis. Okay, one more, then I'm done. Okay. 25, last one of this section I'm going to go over with you guys. And again, you have the rest of this hour after I do this one. And then you have all day on Monday to finish this thing up. Okay, and I have to alter one more thing here, okay? Zeros on number 25 are 4 and negative radical 5. Again, what I've told you isn't wrong, but I need to add to it, okay? I gave you 2 zeros. So what degree do you think it's going to be?
2.
Good guess, and that's what you're supposed to say, and it's wrong. It's not second degree, it's third degree. And here's why, okay? I just told you that imaginary ones come in pairs. Are those hang on, are those imaginary?
No.
He already said earlier, how do you know they're not imaginary?
Is there on here?
There's no why. They're not imaginary, okay? Here's what I say, and you're not going to read this in a math book, okay? Weird answers come in pairs. And what the heck is a weird answer? One type of weird answer is what we just did in the last problem. What's one thing that's weird? Imaginary ones, okay? Something else that's weird?
Right.
Radicals. Now be careful here, okay? Is this a weird number?
Yes.
Radical 9, is that a weird number? Think about it. Is that weird?
No.
Why?
Because it's a square.
It's what? What is that?
It's 3.
It's 3. Okay? Is this weird? No. It's 5. Is this weird?
Yes.
No, it's 13.
No, it's not.
Yes,
really
it's
not.
weird. It's
13
square.
times 13, not 13 times 2. Don't just chop it in half.
Oh.
That's okay. A lot of people think that, okay? I don't know what that is. It's 5 point
That's
something.
a weird one then.
Yeah, it is weird. This isn't, though, and this isn't, okay? Is this weird? Yes, it is. So if negative radical 5 is a 0, what's the other 0 that they didn't tell you?
Radical 5.
Now, if 4 is a 0, must negative 4 also be a 0? No. Okay? So I say weird answers come in pairs. And what makes something weird? Imaginary and square roots of things that aren't squares. Okay?
This is gonna
Oh. How many imaginary are there going to be?
2.
Careful. How many imaginary are there going to be?
Oh, it's
None. Why?
Because they're real numbers.
Why?
There's no I.
Very good. We already had this conversation, didn't we? So, exact same conversation, I think. All right, yeah, they're weird, but they're not. It's third degree, and it will touch the axis in 3 spots. Because even though they're weird, what did you just say? They're weird, but
They're real.
they're not imaginary. There's no why. They're going to touch the x-axis at these spots. They're not very nice numbers, but they're not imaginary. All right, so x minus 4, x plus radical 5, and x minus radical 5. One last thing before I actually start this problem out right here. Is it really important where I put the negative? I mean, could I have accidentally put the negative in there? Is that okay? Could I have slipped that negative there? Is that cool too or not? No, because what's that?
That's radical
negative
five.
radical 5.
And what's that? What's a negative inside a radical called?
Imaginary.
That is imaginary. And that's wrong for several reasons, okay? It changes it, plus you can't just have one imaginary solution. They come in pairs. All right, which 2 you want to do first? The first 2, last 2, or first and last?
First and last.
Ugh.
No,
Well,
first.
I'd do the last 2. How come? Similar. They're the most similar. It's just easier if you do the most similar ones, okay? So if we FOIL this out, x times x is x squared. Outers, x times negative radical 5 is negative x radical 5. Inners, radical 5 times x is also, or the positive x radical 5. And our last, radical 5 times negative radical 5 is negative radical 25. Well, what is radical 25? 5. Okay? These cancel, and we're left with x squared minus 5. And we still have times by x minus 4. Okay? So let's FOIL this out. And I tell you what, I'll give you a chance to really impress me here. I am not going to FOIL. Try to do this without actually, if you're working, please stop writing for just a second. Let's see if you guys can figure this out without actually writing it out. I am not going to FOIL. I'm going to file. That's not a joke, okay? Any idea, and it's okay. I mean, there's nothing special about FOIL. You can file if you want. You can LOIF, okay? It doesn't, LIFO, it really doesn't matter, okay? It's just FOIL is a word that you've heard before, okay? Why is KO going to do file instead of FOIL? Do you see it? If you can do this in your head, you'll see it, okay? And that's okay if you can't. Okay, why is KO going to file instead of FOIL in this on this particular problem? No? What?
It puts it in standard form automatically.
What do you mean?
So if you do that, then it makes x3 the first one, then it also puts the x squared next.
It's not just timesing everything by everything, it's putting them
In standard form.
in the right order. It's putting them in the right order, okay? If I FOIL, and there's nothing wrong with this, I'd have x to the third, then I would add negative 5x. If I do my outers next, it's negative 5x, and my inners would be negative 4x squared. Do you like the order they're in? No, you want to have the x squared before the x. If you, and again, there's nothing wrong. I'm going to finish out, plus 20. But if I filed instead of FOILed, it would put them in the right order on this one, okay? So x3 minus 4x squared minus 5x plus 20. Now, that being said, will the computer accept this answer? My short answer is, I don't know. I don't know. And it's not that I want to get you, but on a written test, if you wrote that, I really probably should take a point off. And I probably would take a point off, okay? Because it's not in the right order, okay? It needs to be in this order. Okay, third degree. Does it ever touch the x-axis? Yeah, how many times? Three. Three times, okay? Yeah, they're weird, but they're not imaginary, okay? All right, so that's it for this section, okay? So you have the rest of the hour you can work on it. You have all hour on Monday you can work on it. Again, some of these are really, really simple. Some of them take a little bit longer, okay? All right, rest of the time's yours, guys. Did I? Let's see, hand, you have all the answers. I gave you the answers to 16, didn't I? You guys are all set now, I think. Yeah, okay.